Welcome back to Plantopia. Plantopia is the plant health podcast of the American Phytopathological Society, and I'm your host, Matt Kasson. I'm an associate professor of forest pathology and mycology at West Virginia University. This is the 6th episode of Season 4 of Plantopia, and today we are headed north to Quebec, Canada, to speak with Dr. Edel Pérez-López, associate professor of plant pathology in the Department of Plant Science at Université Laval, where he specializes in obligate biotrophic pathogens of plants, including protists and phytoplasmas. Dr. Pérez-López completed his BS in biochemistry at the Universidad de La Habana in Havana, Cuba in 2011, and a PhD in ecology and biotechnology from Universidad Veracruzana in Veracruz, Mexico in 2016. Before taking on his role as professor at Université Laval in 2020, he completed 2 fellowships, first in the Department of Plant Pathology and Entomology at Auburn University, and then in the Department of Biology at the University of Saskatchewan. Dr. Pérez-López oversees a large lab and has already established a reputation of tackling difficult questions in and around the systems he studies. He's a recipient of numerous grants and of numerous awards, including the CBC's Saskatchewan Future 40 Under 40, the Schroth Faces of the Future Award from the American Phytopathological Society, and the 2024 Next Gen Leader from Seed World magazine. He's published over 70 academic papers with over 60 as senior or first author, and he teaches courses in and around phytopathology and technology. Dr. Pérez-López is an active member of the American Phytopathological Society and the Canadian Phytopathological Society, as well as the Canadian Society of Plant Biologists. Edel, I'm really excited for you to be here today on Plantopia. You work on some really interesting parasites, obligate protist parasites, mollicutes, you name it. I'm excited to hear more about them, but also hear more about you as a plant pathologist.
Yes, I'm really excited to be in Plantopia. I've been a fan from the beginning, and now with you as a host, I really love it too.
It's hard to live up to the work that Jim Bradeen did and David before that, but I'm happy to be here. You grew up in Cuba. You're Cuban, and you got your Bachelor's of Science there. Could you tell our listeners a little bit about what life was like growing up there and how those experiences maybe shaped your decision to study biochemistry?
That's a really interesting question. I think that, in fact, it's Cuba what made me become a plant pathologist. We have to do a thesis in Cuba, and I did my undergrad in dengue virus. And I was in love with that subject, but in Cuba, to go out of the country, you needed a letter of the government saying that you could go out of the country. And I knew that I wanted to do grad school in other country, not in Cuba. If you work with biotechnology and human-related subjects, you were in a kind of a list that you could not go out of the country. And then that's why I said, okay, what area the government doesn't care too much that I can work? And it was agriculture.
That's interesting.
Yeah, so I decided to start working in a research institute focusing in fruit crops. And I really became in love with plants and plant pathogens. I was working with one long bean, HLB disease. Mm-hmm. You probably have interviewed people that work in the subject. Was a big problem in Cuba. And we were working in diagnostics and management. How can we reduce the dispersion of the disease? How can we control the insect vector, the Aphorina C3? So it was a big change, but it was a very good experience for me.
And after that, you moved to Mexico for your PhD. You worked on HLB during your time in Cuba, and this was after you finished your bachelor's degree in 2011. So we're talking the period from 2011 to 2013. And then what was the experience like going from there to Mexico? Obviously, there's no language barriers when you're moving, although I hear Cuban Spanish is a little bit different. But what was the research experience like there? Did you work on maize diseases there?
Yes, that was also a interesting change. There is no language barrier, but there is a cultural, and also in Cuba we speak really fast. and we have our own words for things. Surprisingly, when I arrived to Mexico, people barely understood what I was saying. So it's a cultural change, and I had to adapt what words to use in what situation and learn many things. But the common things with my previous work is that in Cuba, I also work with phytoplasmas. So basically, I was working with a obligate unculturable bacteria. So in Mexico, I started with another subject. I changed supervisor, and that's something that I always like to mention, that if you are not comfortable with a supervisor or with the research subject, don't be afraid of change. I lost 1 year my PhD, but I found an amazing supervisor that gave me a lot of freedom. And he basically said, what do you want to work? Because in Mexico, we have a government scholarship, so it's not tied with a grant.
Okay.
You have your own funding for your support, and then if the supervisor have a little bit of funding for the research, you can do it. So I said, okay, there is this disease, mice bushy stunt, that is caused by phytoplasma, and nobody has searched this disease in native varieties of corn. And Mexico is the place of origin of corn, so they have this amazing biodiversity. So I decided to switch and work on that for my PhD, trying to look for the vector, characterize the disease. During my PhD, I applied to a travel scholarship, and I was able to come to Canada in Saskatchewan with Christelle Olivier, that she was one of the pioneers, I think, in phytoplasma here in Canada, working with Acegelo phytoplasma. And this is how I was able to do all the molecular work, because we didn't have basically a lot of resources in the university where I was in Mexico.
But bushy stunt phytoplasma on maize is a real problem there.
That's right? Also a really good question. In general, I would say that there are only some crops where phytoplasma is a real problem. They can be a real problem some years, but other years they are not a big problem. And the main reason is because of the heavy application of insecticide that some places do as a management strategy. So if you apply a lot of insecticide, you don't have vector, and then you don't have disease. But in the communities, we found that they have more than in the big extension producers. So in communities, they have more problem because they have less access to insecticide, but they don't really know that they have the problem. And that's what we found. They didn't know they had the problem. They sometimes think that is physiological. The corn didn't grow well, or the plant is red. So sometimes they were applying a lot of fertilizer that can cover the symptoms for a while, but at the end, it doesn't have any production.
Yeah, I think we see the same thing with elm yellows. I recognize that it requires a fair amount of insecticide to control those diseases. So you worked on maize for a while. You had this real great opportunity to do molecular work in Canada. Now, obviously, you're in Canada now, but there was a 1-year postdoc I think you did in the U.S., right? And
yes.
You want to tell us a little bit about that real quick, what you worked on?
Yes, that was a really great experience. I was in Auburn University with the current editor-in-chief of Phytopathology, Leonardo de la Fuente. And I learned many things about HLB. It was also a project about HLB, but more focused in trying to culture this pathogen. You probably know it's still not culturable because it's a really huge challenge. And we did some research. We tried to replicate some of the conditions that the pathogen can encounter during the infection in the plant, but it was really a big challenge, and sadly we didn't have a lot of progress. But one of the things that I think that it was really good out of this experience was a review that we wrote for phytopathology, and we put together what could be the best scenario if we can culture this pathogen, Candidatus liberiobacter asiaticus. That review has been cited a lot, and it's one of my most cited papers, to be honest. And it's because we really did a great job putting together what can we do to culture this pathogen, but it's very complicated. That's the short answer.
Anytime you're working with fastidious prokaryotes, there's always challenges involved. I also work on some obligate biotrophic fungi like that infect insects, and I think a lot about rust pathogens, although I don't work with rusts. I just think about the challenges. And for the listeners out there that may be less familiar, there are some plant pathogens we can't culture in the lab. We have to study them under field conditions, and we can harvest spores and inoculum and reinfect plants. But it's a real challenge to study it separate from its vector, separate from the plant. And it's challenging, but also it's inspiring, because when you actually make a breakthrough, it's because you put in all this work to figure out something that a lot of people hadn't figured out before.
Yes, and that's part of the things the group was trying to do, was trying to use also another Liberibacter as a surrogate to try to study then Candidatus Liberibacter asiaticus. So many different strategies we were exploring, but I didn't stay in US not because of that I don't love the community. I love the plant pathology community. That's why I'm involved with the society so much, but more for personal reasons. I was engaged with a Canadian. So I decided to try to find another opportunity here in Canada, and then I came back to my second postdoc.
And that was where?
That was in University of Saskatchewan. So I returned to the place where I did an internship a few years before. I returned now as a postdoc, and I switched to another pathogen now that unfortunately is also unculturable. But this time it's an eukaryotic pathogen, a Plasmodiaphora brassicae.
I love the fact that you jump from kind of pathogen to pathogen, these groups that are like highly specialized, hard to work with. You seem to lean in head first, going from working on these phytoplasmas to working on these biotrophic protist parasites. Obviously, in your world, a lot of people know about the Clubroot pathogen, but maybe our listeners are not familiar with it, and they're less familiar with how biotrophic protist parasites work. Could you explain generally, in layman's terms, a little bit more about the pathogen, what its host range is, and what host you're looking at and trying to understand?
Yeah, that's a really good question, because I have received reviews saying, your bacteria. And I want to clarify, it's not a bacteria, a fungi, or an oomycete. It is classified as a protist. And what is the closer thing? Maybe the closer one, plant pathogen, could be Spongospora subterranea, that probably people know better in US, that affect sugar beets. Mm-hmm. So Plasmodiaphora is a obligate parasite. It's a soil-borne pathogen. So it forms resting spores. These spores can survive up to 20 years in the soil.
Oh, wow.
It's really hard to get rid of it once you have it. And the host range mainly are brassicas. So we have cruciferous crops. We have a cauliflower, broccoli. And here in Canada, we study a lot canola, or rapeseed, how it's known also in Europe, because it's a very important crop for the Canadian economy. It's $29 billion per year industry.
That's huge.
Yeah, it's the more important crop here in Canada. After, there is only soybean and maybe corn, but canola is number one. There is a huge industry in mainly 3 provinces in Canada, but the pathogen is very challenging because it can only multiply inside the plant cell, mm-hmm. and affect the roots only. And during the infection, it has 2 infections. It has primary infection and it has secondary infection. During the secondary infection, it forms galls or clubs in the roots of the pathogen. Mm-hmm. And this is the main reason why it's a big problem, because the plant cannot acquire water or nutrients and then eventually die. We also see that the plant barely produces when it's infected. So at the end, you have these big areas that doesn't produce, and it can be a big challenge when you have it in the field to get rid of it.
So it's not a root rot pathogen. It basically just, it changes the efficiency of the roots so that water uptake is just diminished considerably.
Yeah, exactly. It changed the root architecture, and eventually when the disease progress, you see that it start to get rotten, the root. But it's because it's a place where accumulate the water over there, and instead of going through the plant, the water start to accumulate in this gall and also the nutrients, and it's so sweet that even other pathogens start to infect the roots. For example, this is a funny anecdote. We had a flies infestation in the greenhouse, and we had a Arabidopsis plant infected, and we saw that the plants infected with Clubroot, they had no roots because the larvae start eating the galls, and it was like a candy.
Oh, sure. Coming back to this, like, importance to the Canadian economy, you said, like, what'd you say, $28 billion or something?
Yeah, it's around $29 billion per year.
And they give, what, 10% of that to your lab?
I wish, but I cannot complain. Grower Association have been extremely open to the research that we are proposing and we plan to do in the lab. And we have been funded quite a bit by the different grower associations. We have Alberta Canola, Sask Canola, and Manitoba growers, all organized through the Canola Council of Canada. We also have funding from Genome Quebec and our National Council of Science. So everybody has been really accepting about the research that we start proposing in the lab with Clubroot.
Now, you're obviously not in the western provinces of Canada. You're at Université Laval. Clearly, you were doing a postdoc in Saskatchewan, but you're now in Quebec. Could you tell us how that happened? And obviously, the pressing question for me is, you grew up speaking Spanish. You clearly speak English pretty well. Did you speak French at all growing up? And how has that transition been? Because it's really quite impressive that you're fluent in at least 3 languages. There's probably others too.
No, only 3. And I hope I stop there. But yeah, that's a really good point. When I was in Cuba, there was a big migration to Quebec in the years 2010, 2009. So it was very popular to learn French. We have the Alliance Française, that is a French school that have 2 headquarters in Cuba, one in Havana and another one in Santiago de Cuba. And when I finished my undergrad, I started to study in the one in Havana. It's really difficult to get in because the waiting list is huge. Everybody wants to learn a language in Cuba to be able to go to another country. So I made it, and then I was working and going in the night to the French class. But that was 2011 to 2012, so I didn't advance too much. It was only 1 night per week. And then I moved to Mexico, and I stopped completely my French class. Then when I saw the position here, you know how difficult it is to get faculty positions. And many times, the faculty positions, they are very specific. Like they want a potato plant pathologist or this plant pathologist. And this position here in Laval was very general. And I was thinking, I have a chance, let me apply, but I don't know any French. So when I came to the interview, I shoot 1 or 2 words in French here and there, close to Spanish, fake it until you make it, basically.
You must have picked the right 2 words because clearly you're there.
Apparently now, people from the committee said that when I said Montreal instead of Montreal, or Montreal, like many people say, that gave them a good feeling. So I said, I can learn, just I will need some time. They said, okay, you don't have to teach for 1 year. We give you 1 year to learn, and then you have to start teaching after that year. And for good or for bad, I came exactly when COVID started. All the schools were online. Mm-hmm. Then when things moved in person was with a mask. So you can imagine how difficult it is to learn a language when you cannot see the mouth of the teachers.
Right.
So that was a big challenge. But I feel like just being here and doing the things in French, my colleagues were managing to trying to understand me, and all the administration here in the university is really completely in French, and the teaching is in French. And I also have been lucky to have students that are very understanding. If I don't know something, I switch to English and they don't complain. But yeah, part of my tenure application included to have a French test. It's not like I say I learn and that's it. I have to really prove that I learned. And luckily I passed that test, but it was an added challenge on top of trying to have your research program ongoing, to have a student, to have funding. You also have to learn another language, which I feel like many people go through this when they are immigrants, like Latin people going to US, or even American people going to another country to be professor. That happened too a lot.
So does your husband speak French, or did he grow up in Quebec or another province?
That's also an extra challenge that we had to deal because he's from Saskatchewan. People have the misconception that in Canada, everybody speaks French and English, but that's not true. Many people in other provinces, or most of the people in other provinces, don't speak French. And you find also that many people in Quebec don't speak English. Although I think that Quebecois, I would say, are more bilingual than the rest of Canada, if you have to put a balance on that. But he had to learn French full-time. We were lucky that, again, COVID was horrible for everybody, but a good point of COVID is that he was able to slow down and stop working for a year and then go to the school full-time, also with a mask, but he's a pharmacist. So that means that he had to do a test in French about the rules and laws, because that's normal in every province, but here the challenge is that it's in French.
Nothing makes you sweat like a technical test in a second language.
Technical, yes. And then he had to do the language test, also technical. So it was 2 technical tests in French, but after a year and a half learning French, he was able to pass, and now he's a pharmacist completely adapted to Quebec.
Now, I imagine in traveling to academic conferences, you've had the opportunity to speak with French scientists outside of Quebec and outside of Canada. And much like your story about talking about speaking Cuban Spanish and then going to Mexico, are there any language barriers between Canadian French and typical French?
That's a good question. I'm the kind of Latin that has a strong accent in every language. You probably know all the Latins that they can manage to hide it a little bit better, but I'm not. I can't. I have a strong Cuban accent in French and in English, so everybody have this extra layer of complexity when they talk to me.
I like your accent. It's unfortunate we live in a kind of world where in some places people feel that they have to hide their accent or feel like that they can't be them true selves in that regard.
But now I have a story. So between French and Quebec, because, for example, we were in a committee. We are creating a new master in organic agriculture here at the university. Part of the process is to have a committee that evaluates your program, like to external committee. And we have French scientists coming, and the interaction was not the greatest because some words that the Quebec professor was saying, they didn't like it because it's not common use there, and they were being very rude, I would say, in the way they were talking about it. So now I experience also what it is to be discriminated a little bit, speaking a different way. So it's weird because I experienced that as a Cuban and now I experience that as a Quebecois.
Yeah. The thing that I'd like to say is that I think that you're a real role model in a lot of ways, because there's a lot of scientists that are not only trying to navigate their own scientific path, but you've navigated all these language barriers and you've overcome them. And I think that that's the experience of a lot of early career scientists. And there's probably early career scientists that are afraid to take that leap like you did. But I think it's encouraging that you're thriving. You're helping to keep the canola industry running. But I think it's great that people can look to you and say, he navigated 3 languages, so can I.
Yes, so that's something that I always try now to encourage all the postdocs or everybody looking for a job. I always say, you can learn a language, maybe not perfect, but I don't consider myself as somebody that is super good in languages or learning another language, but I feel like sometimes we put that stop in our mind. Oh, I can't because they speak French. If you have a supportive, and this is the most important part, you need to have a supportive environment and a department that really want to help you. And I felt like my department was extremely supportive. And here in Canada, it's also an amazing place to, it's good and it's bad. I have to say this. It's a good place to come and speak another language, but it's also bad to be perfect in the language because nobody corrects you.
Right.
They are so nice. And that is not a fake story. Canadians are too nice, and they will always try to understand what you are saying, even if you are not saying it, and they will not correct you. So that's good and it's bad.
Right.
It advances faster, but you don't learn the language as you should.
Yeah, I feel like constructive criticism is important. Even thinking about the mentor-mentee relationship, I think it's great that also you've just received tenure recently, and now you're in a position where you're more established and you could ensure that these kinds of practices that are standard in your lab will also carry in the department and maybe university-wide. So that's great. I'd be remiss if I didn't mention that June is Pride Month. And we're not quite at the International LGBT Pride Day on June 28th, but as a member of the LGBT community and in Pride Month, I thought it would be a good opportunity to talk a little bit about your experience in terms of, where we are progress-wise. There's been some recent pushback against DEI, and we've seen a lot of that in the U.S., but I think we're seeing that globally. I think our professional societies have been doing a pretty good job of this, and I've talked about it. What's your thoughts on where we are on this and what you'd like to see in terms of how could we improve as a profession? How could we encourage early career scientists that are members of this community to stay in the community because it's an inclusive space?
Yeah, that's a really good point. I feel like we have improved a lot in the last years. One example that now I use a lot is the last year award ceremony. So in that award ceremony, we were 3 members of the LGBTQ plus community receiving a name award in the American Phytopathological Society. That's the first time. 2 of them immigrants.
Mm-hmm.
And that was also one of the first time that this happened. And I take that selfie that we had, the 4 of the 5 name awards, we were 2 women, 2 men, 1 woman part of the community, the 2 men part of the community, 3 of us immigrants. That was a historical moment, in my opinion, when we were able to receive that. And that's an example that things are changing, I think, in my point of view, but not only because there are many layers to this.
And I know we don't have the time to get into all those things.
Yes.
And also there's a lot of, not controversial, there's just a lot of discomfort with a lot of people even talking openly about these.
Yeah. But some of the layers to this is that we got people that nominate us. 1. 2, we had the opportunity to have a CV strong enough that we were able to be selected. Like so many of things that have been changing in time that I feel came to this moment. Because it's not like we were selected from now to tomorrow. We were selected because we were able to have opportunities to do a PhD, to do a postdoc, to have our own group, to have our research, and to have results. So many people in the community don't even get the opportunity to continue their dream to be a scientist because they go to a bad place, they don't have the support. And that's really important for the community. My main advice is do not stay in a place that don't support you for who you are. So That's the number 1. And if somebody tell you that you cannot do something because you are not like the others, say, who is this person to tell me this? Be always careful from whom you listen things. And about EDI, it's a very controversial subject because, in my opinion, we still have to put quality and we have to put excellence. But the main issue is, how do we measure excellence? And I think that this is the key subject that we have to discuss, and not EDI itself. It's like, what is excellence for this group of people and what is excellence for this other group of people? And that comes at the moment, for example, that I get a CV from a student in an African country and a student in a North American country. What opportunities this student had that the one didn't have, and that's why this other one was able to go to 5 conferences, and this other one cannot even come to US because doesn't have a visa.
I thought it was really insightful what you said about all these awardees being immigrants and members, some of them being members of the LGBTQ community. That just didn't happen overnight. What you said is that what was set in motion in the last decade or decade and a half is that there have been more opportunities for these early career scientists. So they're now coming into the fold for consideration for these awards at a time, at a career stage when they're actually eligible to be nominated. So that's good to think about, is that the decisions we make today and the rules that are put into effect today have really big implications for a decade down the road and who ends up on that award stage. But it's not just about awards, just opportunities. Who's allowed to be a grad student in that department?
Exactly. And I'm seeing that even here in my department. So when I arrived, I was the first non-French, non-Canadian professor. That was in 2020. Now we are another professor from Iran, one professor from Tunisia, another professor, 2 more from France, and we are more immigrants. I was the first one. And we also have women, we have members of the community, part of the department that we also didn't have. We had one only that was who hired me and he retired. And so things have been changing. Maybe it required one person to start.
I suspected that there's a tide of change, but maybe everyone just saw your lab space and thought, I really want that space too. It's really funny that we follow each other on social media, and every time I see a picture of your lab, I'm like, is that what all Canadian professors have? It's just such a beautiful space. And clearly you have a big lab. And I think I saw a recent advertisement where you were advertising for 11 positions or something like that. That's unbelievable. Are those all centered around your work?
Yes. So the lab now have officially divided in 2. So now we have Clubroot and we also have leaf hoppers. So I'm becoming a little bit of an entomologist too, because
that happened to me as well.
In fact, I thought a lot about you in a recent conference that I was attending in Janelia campus in Virginia.
Mm-hmm.
It was about extended phenotypes, and everybody was showing pictures about cicadas affected with the fungi. And I was always thinking about you, of course. Yes, we have become an entomologist lab because we start with a little grant about the effect of climate change and a diversity of leafhoppers. And the results were so interesting that I wanted to bring this small Quebec grant to a pan-Canadian thing. So this is not official. I should not be talking about it, but anyways, I will talk about it. It's out there somewhere. We just received a huge grant for 4 years to study the effect of climate change in leafhoppers in Canada, all with the objective to improve the use of insecticide, to try to find a biological control, and to understand how we can implement all these findings with the growers. We are not only working with canola growers, we are also working with blueberry growers and strawberry growers in all Canada. So that's why the lab is growing so much. This is a huge grant for 4 years, and it's all focused in sustainable agriculture. It's funded by the National Council of Science, Natural Science, and Engineering in Canada.
Congrats on that $7 million grant. That's very impressive. I think it's really great that you're working and you have these two pillars of research in your lab. My lab is like that too, and sometimes specialists will say, you're getting too stretched thin over too many topics, but I feel like there's real synergy that happens, and you might develop a method to study phytoplasmas that has real relevance to your protist parasites and vice versa. I feel like that's when those epiphanies really, like, you're creating the conditions for really high-end problem solving.
Exactly. They have a lot of connection, because one of the things that I would like is to have phytoplasma-resistant crops. But it's also what I'm doing with the Clubroot. I want to have Clubroot-resistant crops. And for that, we use similar strategies, using effectors, working with the plant. And I'm this kind of person, like you said, I go head first with different subjects. And everything is interesting for me. And sometimes I have to control myself. Like I said the other day in Twitter, please help. I need help, because I would like to create a new research subject all the time.
Yeah. But that curiosity, you can hone it, but you have to have the seed of it inside you. And I think what comes across is that you are a super curious scientist, and that curiosity is really infectious. And I suspect that if I talk to any of your lab members, coming out of a meeting in your lab, they would feel energized and emboldened to want to, like, better themselves, better their research, because you project that. It's also clear that you're really committed to mentorship, and you've tweeted about this, but I recognize that and talking to you as well, that it's something that's critical to you, because during your first year of your PhD experience, you realized, hey, I don't have a good relationship here with this mentor. I need to change it up. And I think it's good to encourage people to say, if you're in a situation that's not productive for research, but not productive for your mental health and your well-being, then find someone else. That's why committee members exist, to provide that kind of independent support.
Yeah, exactly. I think that's really important. I also love to have a really good environment in the lab. Now, what I notice, you are always learning. You have to find what is the best strategy, because at the end, I don't work directly with the students all the time. They are in the lab, they are doing their job, the trainees. So what we have developed in the lab is more like a voting system, and we all decide who is joining the lab. So the process is longer, but we need to really know that there is a chemistry. I always say, we are not family. I hate when people say we are a big family. Labs are not family. We work with each other, but we spend a lot of time with each other. So we really need to have a good environment and have people that fit to this energy, chemistry. So we now have a long process to join the lab. I don't have the last word. I just suggest, I think that this person can be a really good person, and we all interview the candidates. We all decide, because it's really hard when people don't enjoy themselves in the workplace. It's not a normal job. It's not an industry job. It's a job, but you are also learning. So the speed is different. The process is different. I also try to have resources for the lab members. For example, I have all the contact for the psychologists on campus that take care of the faculty. If you need something, you can contact this person. Sadly, my role ends in only suggest when I feel like it's necessary. And I hope that the student follow up or the trainee follow up if they really need. But at least we know the resources, we know what to do, and how can we offer the best support.
Yeah, I agree. It was a delight having you on, and thank you for your time.
Thank you. Thank you for the invitation. I'm a big fan.
We've just heard from Dr. Edel Pérez-López, Associate Professor of Plant Pathology in the Department of Plant Sciences, University Laval. As always, be sure to check out the show notes for this and other episodes immediately following each episode's description at our website, plantopiapodcast.org. I'm Matt Kasson, host of Plantopia. Thanks for listening.